Today's lesson is on polynomials. In today's lesson, you're going to want to make sure that you have a lot of different colors to take your notes, some highlighters. It'll allow you to see information much more clearly, and it'll increase your learning and understanding. So let's get started. So polynomial classification. Polynomials can be classified or named, because that's what classification means, in two different ways. The first is by the degree, or the largest exponent in the expression. The second is by the number of terms in the expression. So you have two different ways that we're going to name them. The first is by looking at the exponent. The second is by looking at how many terms are in the expression. So let's look at some examples. And again, make sure you copy these down so that you have them so you can refer back to them. So on the left column, you have degree. On the right column, you have the number of terms. So a first degree, and that's how we're going to do it, is an exponent to the first power. An example of that one is 3x, because x is to the first power. Okay, and it has a coefficient of 3, which is not really relevant in the classification. A second degree would be an exponent to the second power. So an exponent to the second power, the example that we're going to write in black would be 5x squared. So the x squared says that it is a second degree. The third degree is going to be an exponent to the third power. So you have negative 2m to the third, and the exponent of 3 is the third degree. Okay, if you had a fourth degree, you would have an exponent of 4. If you had a fifth degree, it would be an exponent of 5. So that's what the degree is referring to. With regards to the number of terms, you have a monomial, and we've talked about monomials before. It is a one-term expression. Almost ran out of room on there. Readjust for you. There we go. And a one-term expression would be something like 6xy. A binomial is a two-term expression. And an example of that would be 12m minus 3. 12m is your first term, 3 is your second term. A trinomial would be a three-term expression. 5x squared minus 2x plus 3 is an example of a trinomial. And those are, we're going to get into a polynomial where we have 4 terms, but that's about as far as we're going to go for this unit. Okay, let's look at some examples. It says classify each polynomial by its degree and the number of terms. Well, as I look at the first one, I'm going to highlight or circle all the exponents. I have an exponent to the power of 2 and an exponent to the power of 3. So the 3 is the larger exponent, so this is going to be a third degree. It doesn't matter if it has a 2, we're only looking at the largest exponent. Then I'm going to look at the number of terms. We have 2 different terms, so 2 terms is a binomial. So we have a third degree binomial in the first expression. In the second expression, I'm going to look again at their degrees. So I circle the exponents, and I have a 3. So again, we are dealing with a third degree. And then how many terms do we have? We have 1, 2, 3 different terms. So a third degree trinomial. Okay? I'd like you to try example C and D on your own and see what you come up with. And we'll go over them in class. Come and talk to me when you complete them. The next part, it says polynomials in standard form. So there are specific ways that we are going to write polynomials, and there is a correct way to write them. So here we go. If a polynomial has only one variable, write it in order of decreasing degree. Okay? Meaning, and the first number is the lead coefficient. Okay, let me go back to the blue writing. So meaning if you have a fourth degree, an exponent of 4, an exponent of 3, an exponent of 2, you're going to write them in decreasing order. Okay, so let's look at an example. We have the fourth degree polynomial in standard form. So we have 5x to the fourth minus 7x to the third plus 8x squared minus 1. And you'll notice that the exponents go in decreasing order. 4, 3, 2, 1. And when we're talking about the lead coefficient would be right there, the coefficient of the largest exponent, and the lead coefficient would be 5. Okay, let's look at a few more examples. And we are going to write each of these in standard form, then give the lead coefficient. So the first thing I want to look at is the largest exponent. That would be my first term. So negative 4x to the third. Then I'm going to look at the 2, which is my second term, minus 2x squared. Then I'm going to look at the third term, plus 20x. Then I'm going to look at the fourth term, plus 1. And my lead coefficient, I'm going to circle it in black, would be negative 4. And I'll write it down here. Lead coefficient. Okay, I would like you to practice the next two on your own, writing them in standard form and then giving the lead coefficient. Again, in standard form is decreasing exponents, and the lead coefficient is the coefficient of the first term. Oh, there's my answer. Sorry. On the next slide we have, it says simplify polynomials by combining like terms. So as we look at the first one, it says same variable, same power. So you see r squared plus 5r to the third plus 2r squared, and you see the arrows connecting the r squareds. They are like terms. So the answer to that would be, when we write it in standard form, 5r to the third, and then we're going to combine the r squared plus 2r squared. You get plus 3r squared. For combining like terms, to simplify each polynomial, the example down there, let's look, and we're going to find the like terms. We have negative 2y to the third and plus 2y to the third. And they're going to cancel each other out. Then we have a negative 8y squared plus y squared. And when you combine them, you would get negative 7y squared. So when you simplify this polynomial, it would simplify to negative 7y squared when you combine like terms. Okay? Moving on, this is the last slide that we have. We're going to do a couple of examples of combining like terms and simplifying each polynomial. So I want to look for the terms that have the same variables to the same powers. And I see that we have negative 4p to the fifth q to the fourth plus 3p to the fifth q to the fourth. And since they are like terms, we can combine them. So negative 4 plus 3 would be negative 1, or negative p to the fifth q to the fourth. And then I see that we have p squared q to the third and negative 4p squared q to the third. Those are like terms, so we can combine them. And 1 minus 4 would be a negative 3 p squared q to the third. Okay, so again, when we're writing these, we want to write these in largest exponent to smallest exponent, so in decreasing order. So let's look at example B, and I'm going to help you out a little bit. I'm going to show you the like terms. So the largest exponent would be a negative a squared and plus 3a squared. Then ab and negative 5ab. And then plus 4 squared, simplify that exponent, get that into a number, and then combine it with your 10. And then try that challenge problem at the bottom. Okay, good luck. If you have any questions, watch this video again, and then ask somebody around you or your teacher for a little assistance if you still don't understand. Have a good day.